How do we teach math in the era of AI? On this channel I talk about mathematics, the counter to calculus curriculum framework which I've put together, and I have a great question from a good friend of mine asking about the adaptive nature, or like an adaptive teacher for mathematics. How do we integrate? Well, one way I'm going to respond to this question is basically, how do we integrate AI or just the tools available to teaching mathematics well? I think that the first step to excellence in math needs to be answering the question, what is the goal and what's the destination? So for me, the destination and the goal is at least calculus, statistics, linear algebra, data science. I want to see every student get to those courses. And so how do they get there? And what's the most efficient way for them to get there? Before I answer that, I'm going to actually tell you a better goal, and then we'll go back. So right now, in many states in America, students are not required to take calculus in order to graduate. The percent is about 20% of students take calculus when they graduate. In some states, it's 4%. That's not good, because for several reasons. One of the reasons is that many students graduate without a solid math foundation. So if they decide they want to become engineers after they're done with high school, they're actually going to be at a disadvantage in terms of the timeline of 4 years. If they want to do 4 years, they probably might need more time. And that's okay. Nothing wrong with doing 6 years, 5 years, or 6 years if that's what the student needs to do. But why do we have to allow that happen? We can solve that problem by encouraging more students to take calculus before they graduate. In Nigeria, which I have the Nigerian math textbooks behind me up there, in Nigeria, students are actually required to take some level of derivatives and integrals in 12th grade before they graduate. So everybody is learning a little bit of calculus in Nigeria. It's sprinkled into the curriculum at the end of as part of the 12th grade curriculum. Now, Nigerian students actually do have an advantage when it comes to mathematics because they do general maths, which everybody does. But then there's Advanced Math 1 called Further Mathematics Pure, and there's Advanced Math 2 called Further Mathematics Applied. So a Nigerian in 10th grade is actually taking 3 math courses from 3 different instructors if they have a school that is well funded. In 11th grade, they take 3 math courses. In 12th grade, they take 3 math courses. So in 10th, 11th, and 12th grade, Nigerian students are taking much more, like they're doing way more math, and they don't have a full 3 months off in the summer. So that's one of the things that America can learn, is reducing the sort of this summer break when it comes to mathematics. I understand that this is going to be tough to do in this day and age, but parents can provide extra resources for their students to do that. So I would highly recommend that parents help their children learn math year round, provide them with the tools to keep learning. Okay, so now how do we use this adaptive feature? The way I would say that we use the adaptive feature is that we encourage students to basically have a roadmap, which I've created and I'll send to you. If people want it, they can reach out to me, or amosthemathguy@gmail.com, or I'll send it out. I'll put it on my website eventually. But I've created this this strategy of using OpenStax textbooks to take the first course, which is pre-algebra, the second course, which is elementary algebra, and the third course, which is pre-calculus. If you take those 3 courses, you're completing 11 years of math, essentially, or math concepts that are spread around, about 11 years of math, and you're condensing it to just 3 volumes. You finish those 3 books, you're ready for calculus. Like, if you understand everything in those 3 books, you'll be one of the best students in calculus. And so what I've done is I've created a roadmap from pre-algebra all the way to differential equations, as well as now we're adding data science. So if you take those 16 workbooks, you basically cover all the math and you go at your own pace, right? The next step is we need to find a way to bring an AI tool to help students navigate. It's almost like a mountain they're climbing. And so what we've done is we've created these series of workbooks that follow a set of textbooks that can help a student move at their pace and never have to be sitting there wondering, what am I going to do next year? Because they're moving along every day towards a destination. What is that destination I wanted to talk about earlier? That destination is, I want students to be able to understand Einstein's theory of general relativity while they're still in high school. I want them to have all the math they need to do that. So when you have a goal like understanding Einstein's theory of general relativity, or you want to understand how rockets work and the mathematics of rockets and space science, if you have that as a goal, then we can give you all the tools to get to that destination. And for the example, for example with rockets, and then you can actually use all the math you've learned in a practical way. The math you're learning is taking you to a defined destination for a purpose. The other thing that is important, and why I believe we need to make calculus mandatory, is because calculus becoming a mandatory course will force students to recognize that they need to learn the material before them, because it will be used when they get to calculus. But when we remove calculus as a requirement and we tell students, no, learn this material just to learn it, well, the problem is what's going to happen when they keep moving along the way and they get to calculus, and they don't have to go to calculus, and some of them decide, I don't really care about learning this material, then we have a problem, right? So if they're moving along and they don't care about the destination, some of them are going to drop out. Now, somebody might argue and say, well, Amos, can't they just learn the material for fun or just for its own sake? I'm not opposed to that, but let's be honest, is that what's really happening? Like, a lot of students are just trying to do it I'm just doing my homework so that I can go play games, right? Mathematics for Human Flourishing by Francis Su talks about the idea of helping students to just learn mathematics, appreciate the process of learning mathematics. Not so much for the applicability, which it has a lot of applications, but you build certain skills as you learn mathematics. So here's my advice. Let's keep calculus as a standard expectation for every student in America. At the bare minimum, let's do that, especially in this age of AI. And then let's look at the option of those who want to go into engineering or physics or chemistry. Let them have a roadmap that they can be, for now we're using human tutors to guide, right? But eventually I want tutors to work alongside an AI tool and an adaptive learning environment to help guide the student from basic addition all the way to differential equations. And some of those students will be ready by the time they're 15 or 16 or 17. But it shouldn't be limited by any state standard or any country standard. Instead, they should have a guide. That's part of what this tutor training is about. Let's help guide students from basic mathematics all the way to the most advanced math course they can take, while seeing the applications in chemistry and physics and economics. I'm available to help more families do that. We're building a tutor training network, and this is part of this initiative. And the question about adaptive, this adaptive aspect to teaching mathematics, I think is excellent. So thank you for that question. I look forward to answering any other questions to provide excellent math resources for families here in America and beyond. Thanks again for watching. Take care. We'll talk to you soon.